So student, first of all, I'm going to write down structure of quinoline. I hope everyone remember the structure of quinoline. In quinoline, benzene ring is attached with pyridine. So as you know, this ring is pyridine. Sorry, this ring is a benzene ring, and this ring, which is marked as blue, is a pyridine. So quinoline is made up of these two rings, pyridine and benzene. So which is the starting material for this synthesis, or what is the step number one? Step number one is glycerol is dehydrated by concentrated sulfuric acid to give quinoline. So right here, step one. Glycerol is dehydrated by concentrated sulfuric acid to give acrolein. So student, this is the step number one. Now in this synthesis, we first know what is the structure of glycerol, right? That is important thing. Glycerol is a compound which contains three OH groups. Then dehydration means there is a removal of water molecule. And at last, acrolein. Acrolein is nothing but compound which contain double bond as well as aldehydic group. So these three things we should know to understand this step. So first I draw structure of glycerol. As I told you, glycerol contained three hydroxide groups, three OH groups, OH number 1, number 2 and number 3. After that, here we have to add concentrated sulfuric acid. Now what is the use of this concentrated sulfuric acid? Now this concentrated sulfuric acid is used as a dehydrating agent. Dehydrating agent means agent or compound which remove water molecule. So concentrated sulfuric acid is used as a dehydrating agent. So where or how many molecules of water molecules are removed? See here, this OH group, one hydrogen from here and one hydrogen from this oxygen. So total how many water molecules are removed here? 2. So right, there is a removal of 2 water molecules. See what type of structure form with removal of this water molecules. Like this, right? Because OH, okay, I give number 1, 2, 3, 1, 2, 3. So from carbon number 1 OH is removed, from carbon number 2 OH is removed, and from carbon number 3 one hydrogen from carbon and one hydrogen from oxygen is removed, and that's why here we get double bond, and here also we get double bond to satisfy the valencies of carbon, and the compound form here is called acrolein. So this is acrolein. Acrolein is nothing but aldehyde containing double bond, that is called acrolein. I hope everyone understand this reaction. Please quickly go to your chat and tell me you understand this reaction. Please everyone go to chat. Okay, so messages are coming. Okay, so everyone understand this step. So step 1 is formation of acrolein. Now we go for step number 2. One minute. So student, now step number 2. Now this step number 2 is reaction between acrolein and aniline. Reaction between acrolein, which is formed in the step number 1, and aniline. To give 3N-phenyl 3N-phenyl aminopropanol. So this is the step number 2. Again I repeat, step number 2. Step number 2 is nothing but reaction between acrolein, which is formed in the step number 1, and aniline to give 3N-phenyl. N-phenyl is in bracket aminopropanol. You can see here, this is the step number 2. So let's study this step. So first, I am going to write down structure of aniline. So I write aniline like this. This is the aniline. And then acrolein. We can write structure of acrolein like this. You can compare structure of acrolein. It is same. Okay. I write numbers here again. Right. Carbon number 1 and 2 contain double bond, and carbon number 3 contain CHO group. Okay, so what type of reaction takes place between these two? Reaction is very simple. The reaction takes place between two is called addition reaction. But this addition reaction is called Michael addition reaction. This is the name of this type of addition. So this is Michael addition reaction. Now in this Michael addition reaction, what is happened? Okay, I tell you. First of all, bond between carbon and carbon is going to break. Which bond is going to break? Carbon carbon double bond. So for this purpose, this bond is break towards this carbon atom, right? So this carbon atom become negatively charged and this carbon atom become positively charged. Now which bond is going to break in aniline? Bond between nitrogen and hydrogen. This bond is going to break. So I write, so as I told you, this bond is going to break and this bond is break towards nitrogen. Due to this, nitrogen become negatively charged and this hydrogen become positively charged. Okay, so negatively charged carbon, sorry, negatively charged nitrogen and positively charged hydrogen attach together, means they form a bond, right? And hydrogen is attached with, positively charged hydrogen is attached with negatively charged carbon. So what type of reaction takes place? Benzene ring, as it is, one of the bond between nitrogen and hydrogen is already break. So here I write CH2, then CH, and here C double bond O H. Okay, now this CH carbon is negatively charged, that's why one hydrogen is attached here. Which hydrogen? This hydrogen, which is in aniline. It is attached at this carbon atom, so you get CH2, right? So this compound is called 3N-phenyl amino propanol. Now we're going to see how this name come. So numbering is start from here, 1, 2, 3. Now carbon number 3 contain phenyl group and N. This N means nitrogen. So phenyl ring is attached with nitrogen. That's why it is called 3N-phenyl amino because NH group is there, amino, and this straight chain ring or this longest chain contain 3 carbon atoms along with aldehyde group, and that's why this is called propanol. So it is called 3N-phenyl amino propanol. Now student, please go to your chat and tell me you understand this step also, so that we go for step number 3. Students, please go to your chat and tell me you understand this step 2. I'm waiting for your messages. Okay, thank you everyone. So let's start with step number 3. Now step number 3 is about cyclization. Acid catalyzed cyclization, acid catalyzed cyclization followed by dehydration to give 1,2 dihydroquinoline. So Suran, this is step number 3. In step number 3, there is a cyclization takes place, and this cyclization followed by dehydration to form 1,2-dihydroquinoline. So this is, as you know, this is the second last step. So here I'm going to write down compound which is formed in the step number 2, 3-N-phenylaminopropanol. So how this compound is formed, as you know, CH2, CH2, and here C double bond OH. You can see here the compound formed in the step number 2. This is 3-N-phenylaminopropanol. Okay, same compound I write here. So there is a acid catalyzed cyclization. Now, what do you mean by acid catalyzed cyclization? Acid catalyzed cyclization means there is a acid which is we called as H plus is used as a catalyst here. Now, what is the use of this catalyst? What it going to do? Now here bond between carbon and oxygen is break towards oxygen, right? And this oxygen is attached with this hydrogen. See here. So bond between oxygen and hydrogen is break towards oxygen because oxygen is more electronegative. That's why oxygen is negatively charged, and this negatively charged oxygen attached with H plus. So I write here H. Now, due to this type of bond breaking, this carbon atom become positively charged, right? Now, as you know, there is a one hydrogen on this benzene ring. This bond is break, and this bond is break towards carbon atom. So when carbon hydrogen bond is break, carbon become negatively charged, and this negatively charged carbon is attached with positively charged carbon. So now there is a bond formation between this carbon atom and this carbon atom. So there is a cyclization takes place. So this is the cyclization. Now after this cyclization, there is a removal of water molecule. So this H, OH, and one of the hydrogen from this carbon is removed as water. So students, this is the step number 3. You can see here. Acid catalyzed cyclization followed by dehydration to give 1,2-dihydroquinoline. So in the first step, there is a cyclization takes place because cyclic ring form. Then there is a removal of water molecule to form 1,2-dihydroquinoline. Right, students? Now again, please go to your chat and tell me you understand this step also. Step number 4 is, okay, everyone go to chat and tell me you understand this reaction. By meantime, I'm going to write down step number 4. Dehydrogenation of 1,2-dihydroquinoline to give quinoline. Okay, so step number 4 is about dehydrogenation. So step number 4 I write here. This is the 1,2-dihydroquinoline which is formed in the step number 1. So this step is called dehydrogenation. Dehydrogenation means removal of hydrogen, and removal of hydrogen is called oxidation. So this reaction is nothing but oxidation reaction where hydrogen atoms are removed. So how hydrogen atoms are removed, or what is the use as a oxidizing agent? In this case, nitrobenzene is used as oxidizing agent. Now this nitrobenzene remove one hydrogen from nitrogen and one hydrogen from this CH2 to form our required product. So this is nothing but quinoline. So students, So this is step number 4. Step number 4 is very simple. Only removal of hydrogen takes place to form a quinoline. Now again, I revise all the steps. As you know, we started with scrap synthesis of quinoline. Scrap is the name of the scientist. Here one thing is left. Here I do not show these two double bonds. Okay, so this is the quinoline, and this quinoline is formed, or this quinoline we going to form or prepare by using total 4 steps. Step number 1. Step number 1 is glycerol is dehydrated by concentrated sulfuric acid to give acrolein. So in the glycerol reacts with concentrated sulfuric acid. Sulfuric acid used as a dehydrating agent to form acrolein, where 2 molecules of water is removed. Now step number 2. In step number 2, reaction between acrolein and aniline to give 3N-phenyl aminopropanol. Now in this case, this N-phenyl nitrogen atom attached with this carbon atom due to this type of bond breaking to form 3N-phenyl aminopropanol. Step number 3 is about acid catalyzed cyclization followed by dehydration to give 1,2-dihydroquinoline. Now here there is first step is acid catalyzed cyclization, because acid attached here. There is a formation of OH. Due to this, carbon atom become positively charged and benzene ring carbon become negatively charged because carbon hydrogen bond breaking, and that's why there is a form bond between these two, and at last we get 1,2-dihydroquinoline. Now this 1,2-dihydroquinoline in the step number 4 remove 2 hydrogen atoms. These 2 hydrogen atoms are going to remove by using nitrobenzene as the oxidizing agent to form quinoline as a product. So these are the steps, or these are the all steps, and this is the preparation of quinoline. I hope everyone understand this. If you have any question, you can go to chat and tell me. If you don't have any questions, I will put this recording on Classroom, so you can check there also.